Hey guys, this is Taylor, and today we are just continuing the first part of our network recovery pathways question. So, in the last video, we had discussed lot of pseudo code, lot of approaches, why we are using TopoSort and we are not using Dijkstra. We discussed in detail. So, if you have not watched that video, I will put that in description. So, make sure that you watch that video. Then you come here and you watch this part. So in this video, we'll be dry running the code and we'll be visualizing how our answer will come. Okay, so the first thing that I need to do is creation of adjacency list. Okay, so I will define couple of variables here. So I will not be writing any code. We'll be just writing the variables here. Adjacency list, which will be initially empty. Okay, so the for first node it will be empty. There are 1, 2, 3, 4, 5 nodes. So first node, second node, third node, fourth node, five node. So this is simply 0, 1, 2, 3, 4. Okay. Now my edges are empty for now. Let's try to start a creation of adjacent edges. So this is 6. Okay. And okay, this is 6 and it is going from 0 to 2. Are this is this online? Is this online? So let's try to create that array also. 0, 1, 2, 3, 4. So it's true, 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 false, and true. So is 0 and 2 online? 0 is online, 2 is online. So I will be definitely adding the age. So in 0, I can go to 2. Okay. And the age weight is 6. Okay. Super. Now 0 can go to 1 as well. And its weight is 7. 1 is online, yes. 0 is online, yes. Okay. So from 0 I can go to 1 with age weight 7. Super. Now from 1 where I can go? 1 I can go to 4. Okay. So I will be writing something like this. My essential list will look like this. So 1 I can go to 4. Super. With age weight 5. Can I go somewhere else? No. So I will be also checking 4. Sorry. Yes, 4 is active and 1 is also active. So I will be starting from 2. From 2 I can go to 3. Okay, but 3 is false. So I will be skipping this age. The next node that I got is 3 to 4, but 3 is offline. So I will be again skipping this age. Okay. Now from 2 I can go to 4. Okay, let's write it. So let's go to 4. So from 2 I can go to 4 with age weight of 6. Super. I can close to. So from 3, can I go somewhere? No, I can't because my age is offline. So I will keep it empty. From 4 also, I'm not doing anything. So in the end of the day, my adjacency list become 0, 0, 0, 1, and 1, 7. Okay, this is for 0. Then for first node, I can go to 4, 5, that's it. For second node, I can go to 4, 6, okay. So this will be my adjacency list. So I have created adjacency list and let's create in degree array as well. So how my in degree array will look like? In code we will be doing everything together, but just for this trial and purpose I am doing it here. Okay, so everything will be 0, 0. Now how many edges are incoming to this 0? No, so I have my answer will be 0. How many edges are incoming to 2? 1. So my answer will be 1. How many edges are incoming to this 3? So one edge is incoming and one edge is outgoing. But you can see this is offline, so I will not consider it. Okay. How many edges are incoming to this 4? 1, 2, 3. But this is coming from offline, so I will not consider this. Only this one I will consider. So this one and this one. Okay. How many edges are incoming to 1? I think 1. Okay. So my in degree array will, in the end of the day, will look like something like this. 0, 1, 2, 3. So this will be 0, this will be 1, this will be 1, 3 will be 0, 4 will be 2. Okay. Uh, what is the next thing? We have to find the TopoSort order. Superb, let's find it. So, okay. What is the zeroth node? What is the zeroth node? I mean, node which is having zero in degree. So I think there are two. Okay, the first zeroth node and the third, right? Super. Now let's try to find the topological sort order. So here in this array, I will be storing my answer. Okay, and let's try to iterate. So my in degree array is will look like this. Okay, let's try to write it here. Just give me a minute. I'll write it here. So in degree, super. So I have written something like this. So my queue looks like this. So I will pop the first element. Okay, and I will say, okay, as soon as I pop something, I will add it here. Super. Now, what is the next thing that I need to do? I need to relax the edges, right? So how I will be relaxing? So I will be relaxing this edge first. So I'll be removing this edge. Let's try to write with orange. I think that will be better. So I will be removing this part. So from 2, I am reducing one edge. So let's reduce it. Let's make it 0. Okay. And if I will check as soon as I will decrease some in degree, I will check whether if it make 0, it becomes 0, then I will add it here. Super. Now the next neighbor, I will remove this, and I will make this 0. As soon as this becomes 0, I will add this part as well. Super. Can I go somewhere else with 0 now? No, I can't. Super. So my current answer looks like this. So I have popped 0, so my answer becomes 0 here. I will go here 3. As soon as I pop something, I will add it here. Now from 3, what all places I can go? So this is offline mode. In adjacency list, I can see inside 3 I was having empty. So this was from 0, 1, 2, and for 3 and 4 I was having empty list, right? So I can't go anywhere. So that's why I will just add it here, nothing else. Next thing is 2. From 2, what all places I can go? So from 2 I can go to 4 with age weight of 6. Super. So let's go to 4. Let's relax age of 4. So I will be relaxing this age. First of all, let's add it here. Now I can reduce this to 1. Super. Now, can I go anywhere else with 2? No, I can't. Okay. Now, what is the next stage? Next stage is 1. What all places I can visit from 1? I think only 4. Let's try to relax 4. Let's make it 0. So, very first thing that I will be adding 1 here because I have popped it from here. Now, next thing I relaxed it, so I make it 0. Now, I have added 4 here because this 4 became 0. The in degree of 4 became 0. And there is no other option to visit from 1. Now let's try to move it from here. So from 4, I can't go anywhere else. So I will just add it here, and this will be my topological sorted order for this graph. So I hope till now it's all fine. Now let's try to find the binary search, right? Binary search of it. So I will uh, write for a very short iteration. Let's say I will try for 6 and I will try for 7. So that's binary search we all know. Okay. So let me add the same graph here again, and we'll be checking 0 to 143. So this is my topological sorted order. It looks like this, and we will try to basically let's consider mid equal to 6, and we'll try to find whether that 6 can be my answer or not, and we'll try for 7 as well. Super. So let's try for 6. So I will be only considering ages which are either equal to 6 or greater than 6. Okay. So let's start the iteration from the topological sorted order. So I'm having 0, comma 3, comma 2, comma 1, comma 4. Okay, I will go to 0. I will say what all places I can visit, this place I can visit. Okay, I will visit this because this is equal to 6. Let's visit this. Super. So I reached 2 here, no issue. From 0 to 2, I can go to 6. Now, uh, I will say, what is the distance of going? Let's write in terms of distances. That will be more beneficial. So initially, 0, 2, 3. Okay. So initially my 0 is having 0 distance and all other nodes are having infinite distance. Now I will go here. So would I update distance of 2? Yes, I will update because this 6 is smaller than infinite. So I will update it. Super. What all place I can visit? 1 I can visit. And it is distance of infinite. This is 7. So I will go and I will mark this as 7. Super. This part is also done. Okay. Now I will try to check the next node, 3. So from 3, can I go somewhere else? I can't go because this is offline node now. So these edges are not present in my adjacency list. Super. I will go here too. From 2, where I can go? I can go to 4 with a distance of 6. Okay. But 2 is also having this 6. So 6 plus 6 will become 12. So this is the distance, right? So this 2 second distance will add here. I hope you got it. So this way 12 is better than this infinite, so I will update it. Okay, nice. Now I will go and check this. So will I consider this age? No, I will not. Because this 5 is less than 6 and which is not satisfying my condition. I will only consider ages greater than equal to 6, right? That's why I will not consider this and I will say if for mid equal to 6, I'm having a distance of 12 here. Is it possible? So my answer, my k is 12. So I will say yes. Yes, I can return true because my this 12 is less than equal to this k. Super. If you have any doubt in any of this, first we are creating adjacency list, then we are finding topological order, then we are using binary search on our answer. Then last thing we are just checking for that made that answer is possible or not. If that returns us true, then we will try a better answer. If that returns false, we'll shift to left, right? So let's try to code this part and see whether we understood what we learned or not. So let me quickly define some functions. Create adjacency list. We'll be writing little fast here because this is very long function. So I will be defining adjacency list equal to like this, and initially all values will be empty. My n will be length of online. Now for u comma v comma ages, if you write code in C++ or Java or JavaScript, so code is in description. You can watch that and you can follow me and you can understand that way. So if online of u equal to true and online of v equal to true, then only I will visit that edge, right? So adjacency list of u dot append something like v comma w. Hey, why I'm writing like this? Super. So one thing also I need to do is basically calculating in degree array, and initially all values will be empty, right? As we discussed, and I can definitely increment in degree of v if increment by 1. So I will be declaring one more thing, max h length equal to 0, let's say, and max length is so max of max page comma w. So why am I using this part here? Because I will be using this in a binary search condition. Okay. Now find TopoSort. So to find TopoSort, what I need to have? I need to have access of my in degree array and my adjacency list, right? So adjacency list, let's return these things from here. Adjacency list, in degree array, max age. Super. So I'm not taking it from parameter because this will be accessible to this function because it will be I will be defining these functions, these variables outside this function. So I'm already having access to these variables. We'll see. So for TopoSort, what I need a deck queue, which is a queue in Python. And do I need something else? I think no. Okay. So for node in range and if in degree of node equal to 0, then I can append in queue. Okay, super. Now while queue, okay, I'll be up. I can maintain TopoSort is empty array no node equal to queue dot pop left. I'll be popping the left first value of the queue. I can, as soon as I pop something, I can add in queue. Super. What is the next thing I need to do? I need to visit the neighbors, right? For neighbor in adjacency list, I've defined something like this. Okay. Of node, what I need to do? I need to check, I need to decrease the in degree. In degree of neighbor will be minus equal to 1. And if in degree of neighbor becomes 0, then what I can do? I can add in queue. Super. So that way I will be returning the TopoSort here. So what is the next thing that I need to do? Check valid mid. So I will be checking whether current mid is valid or not. Okay. So for that thing, I will be having distance array, which will be defined as infinity initially, and I will be treating over the TopoSort for node in TopoSort. What I need to do, let's pass this TopoSort here as well. Okay, we will do that later. So I need to visit neighbor in adjacency list of node. I need to check if it should be neighbor comma cost. Did I iterate here as well, right? Neighbor should be actually neighbor comma cost. Okay. So if cost is greater than equal to, I will be having a mid. So is it if it's greater than equal to mid? So in first video we discussed in detail that why this condition exists. What is the intuition behind this? So if you haven't watched the first video, please go and watch that video. That is very detailed discussion on the pseudocode, on the approaches, on why we selected Dijkstra, why we selected TopoSort over Dijkstra, for which optimal thing. Okay. So if cost is greater than equal to mid, what I can do? I can what we were doing. Okay, so I can update the distance of my neighbor, minimum of distance of neighbor, comma, whatever distance I'm having to reach node plus cost. Okay, so whatever goes to reach this neighbor plus the distance of this node. That way, I can definitely get something like this. In last, if distance of -1, which is basically in last node, is less than equal to k, then I can return a true. Otherwise, I can return a false. Super. So we just need to define a binary search now. Low will be 0, high will be minimum of k comma that max age length. Superb. While low less than equal to high. If you have any doubt in this binary search, let me know. We can discuss that also. Low plus high minus low divided by 2. If check valid mid is giving me correct answer of the mid, then I should move towards right. Otherwise, I will be moving towards left. Mid minus 1. In the end of the day, I can return low minus 1, which will be my answer. Now, adjacency method parameters. Let's try to call these functions in order and we will be done. That was a huge code. So if you are watching till now, please like the video because this thing takes a lot of efforts, and do consider subscribing us because things takes a lot of efforts. So TopoSort will be equal to find TopoSort. Do I need to pass anything? No. Now I will be calling this binary search and I will just return answer from here. So let me quickly go through everything. So we have defined max age length here in degree adjacency list. Super. Let's try to run it. I think everything looks fine. Okay, I need to do one thing. Distance of 0 should be 0 first thing. Because we are all we definitely can reach 0. Now this should be fine. Top of sort fine. Everything looks fine. Uh, 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 uh. Let's try to run this. Okay, we are getting accepted answer. Let's try to submit this and see whether that is a correct code or not. That was a huge and complex code, but let's see. Then, yes, we are getting a correct answer. So, I hope you understood the approach and what all things we are doing. I know this is little difficult problem, but this comes with lot of learnings. I have also solved this. I got to learn lot of things. Why we are using TopoSort, why we are not using Dijkstra. What is the tricky part here? The binary search, how we come up with the intuition, something like this. So whenever we have to maximize some minimum or minimize some maximum and we have some constraint like this, then we can definitely go for binary search. We can think of it, we can consider a solution like this. So I hope you liked this video and you understood the whole approach. If you have any doubts, please feel free to comment down and make sure you like this video if you understood, and thank you very much for watching this video.